The global energy system is at a crossroads. A machine of immense power and profound contradictions. At its heart lies big oil, an industry forged in a century of extraction. But today, this giant is adopting a new tool, one that promises a radical transformation: artificial intelligence. This isn't merely about efficiency. It's a fundamental rewiring of how the industry sees the world, from the geology deep beneath the ocean floor to the flow of capital in the corridors of power. The question is no longer if AI will change big oil. It's what it is changing it into. Is this the dawn of a hyper-efficient, cleaner energy giant? The metamorphosis of a carbon-based industry into a data-driven energy provider? Or is AI simply the ultimate weapon in an entrenched battle for dominance, a digital shield to protect the fossil fuel status quo? The Optimizer, AI as the ultimate extraction tool. Our story begins deep in the digital bedrock of the industry. For decades, finding oil was an art, a craft of interpreting faint seismic echoes to map the Earth's hidden architecture. Today, that art is becoming a science of brute force computation. At companies like Shell, proprietary AI platforms now sift through petabytes of seismic data. We are committed to finding new and innovative ways to reinvent our exploration ways of working, explains Gabriel Guerra, Shell's Vice President of Innovation and Performance. The results speak for themselves. Tasks that once consumed 9 months of analysis can now be completed in less than 9 days. These deep learning algorithms don't just see shapes in the dark. They predict rock porosity and fluid dynamics, building a digital twin of the subsurface world with breathtaking clarity. The result is a dramatic reduction in exploration risk and a surgical precision in drilling that was, until recently, science fiction. This is the first and most straightforward argument for AI in the energy sector: AI as the ultimate tool for hyperoptimization. A way to make the process of finding and extracting fossil fuels cheaper, faster, and more ruthlessly efficient than ever before. And this digital revolution extends far beyond the hunt for new reserves. On sprawling refineries and remote offshore platforms, a quiet transformation is underway. Consider BP's proprietary system, Apex. It acts as a central nervous system for over 120 of its global facilities, continuously ingesting real-time data from thousands of sensors, predicting equipment failures weeks before they happen. A failing compressor in the Gulf of Mexico is flagged not by a human operator, but by an algorithm that detected a subtle, anomalous vibration pattern invisible to the human ear. This predictive maintenance has reportedly saved the company over $1 billion by preventing unplanned shutdowns. Meanwhile, in the Permian Basin of Texas, ExxonMobil employs AI to automate the complex dance of drilling. Algorithms adjust drill bit pressure and angle in real time, learning from every meter drilled to optimize the path of the next well. This isn't just incremental improvement. It is a step change in operational efficiency. It squeezes every last drop of value from existing assets and, crucially, makes new, previously uneconomic reserves viable. The logic is undeniable. By reducing waste, minimizing downtime, and increasing yield, AI strengthens the financial bedrock of the fossil fuel industry, potentially extending its lifespan for decades. The metamorphosis myth, transformation or PR. But listen closely to the industry's public voice, and you'll hear a different story. A story not of optimization, but of transformation. This is the second thesis, that big oil is using AI not just to perfect its old business, but to build an entirely new one. The argument is that the same data processing power used to find oil can be repurposed to manage the staggering complexities of a renewable energy grid. The industry's titans are rebranding themselves as integrated energy companies, positioning AI as the essential bridge to a low-carbon future. They point to investments in smart grids, where AI algorithms can balance the intermittent supply from wind and solar with fluctuating consumer demand, ensuring the lights stay on. They showcase AI-driven projects that optimize the placement of wind turbines for maximum power or predict solar farm output with uncanny accuracy. And here, we must acknowledge, the technology works. When Google's DeepMind division applied machine learning to 700 megawatts of wind power capacity in the central United States, the results were remarkable. By predicting wind farm output 36 hours in advance using neural networks trained on weather forecasts and historical turbine data, they increased the value of that wind energy by roughly 20%. We can't eliminate the variability of the wind, notes Sims Witherspoon, DeepMind's program manager, but our early results suggest that we can use machine learning to make wind power sufficiently more predictable and valuable. Similar AI systems have optimized solar panel placement and predicted photovoltaic output with unprecedented accuracy, genuinely strengthening the business case for renewable deployment. This is the metamorphosis narrative, the caterpillar of big oil, using the chrysalis of AI to emerge as a butterfly of diversified, high-tech energy. To prove this vision is more than just a press release, the industry presents its technological showpiece, carbon capture and storage, or CCS. These projects are framed as the ultimate synthesis of old and new. They allow for the continued production of energy from fossil fuels, while using advanced technology to capture the resulting CO2 emissions and bury them deep underground. AI is central to this vision, used to model geological storage sites, monitor for leaks, and optimize the energy-intensive chemical processes of capture. On paper, it's the perfect compromise. A technological fix that allows the existing energy infrastructure to continue operating, while supposedly neutralizing its climate impact. The promise is a managed transition, guided by the engineering prowess and deep pockets of the very companies that define the carbon age. They argue this is not greenwashing, but pragmatic engineering on a planetary scale. The capital truth, what the numbers really say. But a story told in corporate reports is one thing. A story told by the flow of capital is another. According to the International Energy Agency, in 2023 the oil and gas industry invested $30 billion in clean energy projects. An impressive sum, until you realize this represented less than 4% of the industry's total capital spending. Put another way, for every single dollar these companies invested in clean energy, they invested $24 in expanding or maintaining their fossil fuel operations. 24 to 1. The numbers tell a brutal story. While the metamorphosis narrative is publicly promoted, the internal strategy remains overwhelmingly focused on the core business of extraction. Fadi Bairal, executive director of the IE, observes that, for every dollar going to fossil fuels today, almost $2 are invested in clean energy when looking at the global picture, but this ratio reverses dramatically when examining big oil specifically. The investment in AI, therefore, appears similarly skewed. Billions are funneled into algorithms that make drilling more precise and refineries more efficient, while the budget for AI in renewables remains a fractional, almost experimental, line item. Critics argue this isn't a transition, it's a diversification strategy, where the profitable, carbon-intensive core business funds a small, public relations-friendly green subsidiary. If you got a sustainability team working on one thing and another working on enhanced oil production that feels suspect at best, observes Catherine Wilkinson, climate activist and author who once worked for Boston Consulting Group. Mary Heglar, climate essayist and self-proclaimed godmother of green trolling, is more direct. The reason are on social media is to greenwash. And what if carbon capture, the flagship technology meant to bridge the two worlds? It too faces a harsh reality check. The Gorgon CCS project in Western Australia, operated by Chevron, stands as a monumental case study. Hailed as the world's largest, it was designed to capture 4 million tons of CO2 annually. Yet, after years of delays and cost overruns ballooning to over $3 billion Australian dollars, it has consistently faltered, capturing only about half of its intended volume due to persistent technical issues. A similar story unfolds at the Quest project in Canada. While it successfully captures a high percentage of emissions from the specific industrial unit it's connected to, that unit represents only a fraction of the entire facility's output. When viewed in total, its climate impact is significantly diluted. a technological fig leaf on a much larger source of pollution. These real-world failures suggest that CCS, in its current form, is less a planetary savior and more a costly, underperforming technology that provides a license to continue business as usual. The digital fortress, AI as geopolitical weapon. This leads us to the third and most unsettling thesis, AI as a geopolitical weapon. In this view, Big Oil's embrace of AI is not about optimization or metamorphosis. It's about entrenchment, a strategic move to solidify its central role in the global energy market for the foreseeable future. The claim is that by creating a closed loop of proprietary data, advanced analytics, and patented technologies, these companies can build a competitive moat that new energy startups cannot cross. But how? They can do it by leveraging petabytes of proprietary seismic and operational data, gathered over a century, to train algorithms that new entrants can neither afford to gather nor replicate. Data is the new oil, and they own the richest reserves. With it, they can predict market shifts, dominate energy trading, and control the physical and digital infrastructure of energy distribution. An industry advocate, however, would frame this very differently. They would argue that society demands reliable, affordable energy, and that only large, established players have the scale and expertise to manage this complex global system. They would contend that while the investment ratio seems skewed, the sheer scale required to power civilization necessitates optimizing the existing system, which provides 80% of global energy, while simultaneously incubating the new one. From this perspective, AI is not a tool for entrenchment, but the only tool capable of managing the unprecedented complexity of a dual energy system without risking catastrophic grid failure. Technological leadership, they would say, isn't about dominance, it's about stewardship. This battle for the narrative is waged not just in advertisements, but in the halls of power. In 2023 alone, the oil and gas industry spent over $124 million on lobbying in the United States. In Brussels, the 5 largest majors spend over 25 million euros annually. This money doesn't explicitly fund AI policy, but the messaging is clear and consistent, championing technology-based solutions like CCS as the pragmatic path forward, while resisting policies that would force a rapid phase-out of their core product. It is a sophisticated, data-backed argument, using the very tools of the digital age to advocate for the preservation of the carbon age. This isn't just about protecting assets, it's about writing the rules of the new energy game. The human cost, automation's sharp edge. But far from the abstract worlds of data and policy, the deployment of this technology has tangible, human consequences. In the harsh environment of the North Sea, automation is redrawing the map of the offshore workforce. For generations, a job on the rigs meant a stable, if dangerous, career. Today, automated drilling systems and inspection drones, controlled from an onshore office, are steadily reducing the number of hands needed at sea. A veteran maintenance technician, with decades of experience reading the language of a machine, spoken in vibration and hum, now finds his intuition competing with an algorithm. While new jobs in data science and remote operations are emerging, they demand a completely different skill set, creating a looming crisis of displacement for an entire generation of skilled labor. The promise of a just transition feels hollow to those watching their expertise be rendered obsolete by a silicon chip. The fragility question, control and catastrophe. This brings us to a final, crucial question, one of control and of fragility. As we hand over the keys of our critical energy infrastructure to complex, often opaque, AI systems, we introduce a new and unpredictable kind of risk. We have seen this before. In the world of high finance, algorithms designed for hyper-efficiency have triggered market flash crashes, cascading failures that happen faster than any human can react. A smart grid optimized for efficiency might also be brittle, vulnerable to collapse in unexpected conditions. An AI designed to maximize oil extraction has no inherent understanding of ecological tipping points or social equity. It operates only on the logic it is given. The ultimate paradox may be that in our quest to use AI to master the energy system, we risk creating a system that is beyond our complete understanding or control. 3 futures. Which path will we choose? The code being written today in the labs of Houston, London, and Tehran is not just optimizing pipelines. It is scripting the future of our climate, our economy, and our geopolitics. 3 distinct pathways emerge from the fog of uncertainty. Scenario 1. The accelerated transition. In this future, regulatory pressure and market forces converge. Governments mandate that AI investments in energy must flow proportionally to renewable infrastructure. No algorithm can optimize a coal plant without an equivalent deployed to a solar farm. The technology that makes fossil extraction efficient becomes the same technology that makes renewables dominant. By 2035, the 24-to-1 investment ratio reverses. AI-optimized grids handle 70% renewable penetration seamlessly. The oil majors, having pivoted decisively, become energy majors in fact, not just name. Their century of infrastructure expertise proves invaluable in building the distributed energy systems of tomorrow. But this requires political will that, today, remains absent. Scenario 2. The entrenched status quo. Here, AI becomes exactly what critics fear, a tool of perpetuation. The competitive moats deepen. Proprietary algorithms make existing fields profitable far beyond their natural lifespan. CCS projects, buoyed by subsidies and optimistic AI modeling, provide just enough cover to justify continued extraction. By 2040, global temperatures have risen 2.7 degrees Celsius. The energy system is more efficient than ever, but it's still 65% fossil fuels. The transformation was always theoretical. The AI made the old system too profitable to abandon. Coastal cities flood. Droughts intensify. But the quarterly earnings reports look excellent. Scenario 3. The cascade failure. This is the scenario no one wants to contemplate but few can ignore. An AI-optimized grid, stretched to maximum efficiency to balance aging fossil infrastructure with intermittent renewables, encounters a black swan event it wasn't trained to handle, a coordinated cyber attack, an unexpected climate feedback loop, or a supply chain shock in critical minerals. The system, having no human operators who understand it holistically, freezes. Rolling blackouts cascade across continents. The very technology deployed for optimization becomes the vector of catastrophic failure. By the time human engineers diagnose the problem, critical infrastructure has suffered irreparable damage. The aftermath forces a chaotic, emergency transition, more painful and costly than any planned alternative would have been. The choice we face? These aren't predictions. They are possibilities whose probabilities shift with every investment decision, every regulation signed, every algorithm deployed. What is certain is that we are no longer in the realm of if, but of how and how fast. The AI systems being built today carry no moral weight, no built-in preference for a stable climate or a habitable planet. They will optimize whatever objective function they are given. If that function is quarterly profit from hydrocarbon extraction, they will achieve it with breathtaking efficiency. If it is the rapid deployment of renewable infrastructure and the managed decline of fossil fuels, they will achieve that too. The question is not whether AI will transform the energy industry. It already has. The question is, who gets to set the parameters? Who programs the objective function of our energy future? Right now, those with the most data, the most capital, and the deepest roots in the carbon economy hold the pen. They are writing a future that looks remarkably like the past, only more efficient. But code can be rewritten. Objectives can be redefined. And the future, despite everything, remains unfinished, still waiting to be programmed by those brave enough to demand that our most powerful tools serve our collective survival, not merely the perpetuation of incumbent power. The algorithm has no opinion on whether civilization continues. It will simply execute its instructions with perfect, terrible efficiency. The choice of what those instructions are remains, for now, ours.